Herd Structure Simulation Model tool. This tool's main purpose is to project the herd population dynamics as well as the future herd makeup according to herd performance parameters such as age at first calving, replacement rate, or calving interval. The tool runs in monthly steps, meaning that it calculates the number of animals in each animal state every single month. An animal state is the condition of an animal defined by age or lactation, pregnancy, and months after calving. Example, heifer of 10 months of age or cow in second lactation 5 months after calving and 2 months pregnant are animal states. The internal model runs in 2 steps. The first step runs as long as needed to reach a steady state or equilibrium of the adult herd population, and it is independent of the input running time value entered. Steady state is a condition of nature in which the proportion of cows in each animal state remains constant over time. Assuming that a herd normally remains constant in size, all the animals leaving the herd are immediately replaced, and this causes, over time, a baseline herd structure in steady state that represents the dairy herd being studied. Having, for example, the herd projected at 0 months in the model will give a herd structure expected when the herd is in steady state. The second step runs assuming that all the heifers calving enter the adult cow population, regardless of the balance of the cows leaving the herd and the need for replacement. This runs for as many months as requested by the user. For example, using 120 months as the time of projection means that the model will calculate the number of animals in each state at the end of the month 120. Depending on the input data, the herd size could either expand, contract, or remain the same. The user can represent any herd by defining some simple and well-known average herd characteristics, such as age at first calving, percentage of calves born, which is related to the type of semen used, stillbirth rate, percentage of young stock culls, which is calves and heifers, cow replacement rate, calving interval between lactations, and the number of total adult cows, including lactating and dry cows in the herd. Once those values have been entered or edited from the default ones, the tool automatically provides a projection of the herd at steady state, which can be studied in graphical and tabular form. Let's pretend that our default data that appears when loading the tool represents a herd. So let's move the slider, herd projected at, all the way to 0, and we can see the herd in steady state. In the graph, every dot represents an animal state. In blue, the young stock includes calves and heifers labeled as heifers. And in other colors, different lactation of adult cows. The x-axis is the age of young stock, or the months after calving of the adult cows, whereas the y-axis is the number of animals. Hovering the mouse over the dots gives you an exact number at each age or months of calving. For example, we can know that at steady state, we expect to have 43 heifers with age 9 months and 22, 15, and 11 cows at 9 months after calving in first, second, and third lactations, respectively. Down below, we can also see the tabular data of the herd at steady state. The data indicates that for a herd of 1,000 adult animals, there would be about 1,010 total young stock, including calves and heifers. The table also shows that there would be 343 non-pregnant cows, 523 pregnant milking cows, and 133 pregnant dry cows, for a total of exactly 1,000 adult animals. Also, the data indicates that 296 of these animals would be in first lactation, 213 in second, 153 in third, and 338 in later lactations. Without changing any parameters, let's project how the herd would look in 10 years from now, or 120 months by sliding the herd projected at all the way to 120. If we would allow to raise all the calves born and let them enter the adult herd. Doing so, looking at the tables results in an increased number of both young stock heifers to 1,677 and cows to 1,938. This indicates that at the current performance, the farm is producing more replacement calves than needed. This is also reflected in the graph, in which the maximum scale of the y-axis doubled to 80. The number of animals in each state increases, maintaining the relationship between states as we did not change any of the parameters of the herd. Now, using two critical parameters, replacement rate and calving interval, we could find out the break-even point, in which the herd somehow remains at steady state in the long term. First, let's fix the calving interval to a bit more realistic number, such as 14 months. Next, we can play with the cow replacement rate slide, increasing it until we reach a total number of cows close to the original 1,000. For example, I found that a rate of 38.85 the total number of adult cows will be 996.